Okay, we're going to move into 3 dimensions and start talking about solids. You've got prisms and cones and pyramids, spheres, cylinders. This vocabulary is going to be on the front of your packet. You might already be familiar with it. If you're not, that's going to be really helpful. For example, if you had a question about a cylindrical water tower, you would need to know that a cylinder is this shape. But in addition, you need to know what formula they're asking you to use. So you need to understand what volume and areas find you. So I'm not asking you to memorize anything that's on this sheet. Okay, you just need to be comfortable with how to use it. So again, we're going to need to pick the right shape and we're going to need to pick the right formula. So this video is just going to introduce you kind of to some of this vocabulary and what these formulas will find you. So I want to start with my pyramid. So my pyramid, the one that's pictured here, is called a square pyramid. Again, this is on your sheet. It should be in front of you. I'm going to build it by starting with the base, which in this case is a square. I'm borrowing my daughter's toys here. She said it was okay. Alright, now a pyramid, the lateral faces are going to be triangles. So off your base, you're going to put a triangle on each edge. So how many ever sides your base has, that's how many lateral faces or triangles you're going to have. Now this is called a net. This is what a pyramid would look like if it's unfolded. Okay, but I bring the triangles up because they're all triangles. They're going to come to a point on the opposite side, and that's why you only have one base. Okay, so this is a square. Name a pyramid by its base. This is a square pyramid, and that's the one that's shown here in this picture. Okay, all your lateral faces are triangles. Alright, my base can be any shape. I could start with a triangle, for example. I don't know if you can see if I use these bigger ones. Let's see. So I could build triangles off of this. These are isosceles triangles. Those last ones were equilateral. Okay, so my base is an equilateral triangle, and then these triangles come up, and now I've made a much taller triangular, because you name a pyramid by the base. This is a triangular pyramid. Okay, so this formula is generic. You can use it for any pyramid. Okay, so a pyramid is only going to have one base. And by the way, just to make sure you see, this vocabulary is on the sheet in front of you, should be in front of you. This was a square pyramid that we built. The square is called the base. The triangles, the sides, lateral faces. Lats are sides, right? So lateral faces. Okay, so your pyramid has one base. That's very much like the cone. In fact, you could use this formula for your cone, but you wouldn't. You have another formula right here. So you've got a circle base here, a square base here. Sphere doesn't really fit into any category, but the other ones are all going to fit into a prism category because they are going to have 2 bases. So again, I'm going to start with laying it out flat. What is this prism going to look like as we build it? We're going to start with, this time it's a triangle. Okay, this is a triangular prism in this picture. So we're going to start by putting the triangle down. That's the base. In this side, look at this time, look at the sides. Around the sides, how am I building this prism? So prisms are built with rectangles. I'm going to use a square, otherwise I'm not going to be able to fit this on my screen. So a square is a rectangle. Okay, so your triangle base is going to have the 3 rectangles coming out the sides. This time when you bring it up, opposite our sides. So what ends up happening at the other end is it's not a point anymore, but it's another triangle. Okay, so you have 2 bases in a prism. Okay, this is the shape I just built. The bottom and top of this one, okay, the bases are going to be parallel and congruent. This is a triangular prism. Okay, the lateral faces are rectangles. Alright, so I want to show you again, and on your sheet, I'm showing you actually this net I showed with the base down. This is another way they often show it, with the triangles coming on both sides. So again, if we look at unfolding this, you know, something like that, or like this. I mean, but when I see those two congruent sides, I picture lifting these rectangles around, and then those triangles are the bases. Okay, so the lateral faces are rectangles in a prism. Again, your prisms can have any shape base. If I use a square and a triangle here, just to make sure you understand the vocabulary, I could build a rectangle off all 5 sides. 1, 2, 3, 4, 5. This is a pentagon, so this is going to be a pentagonal prism. So I'm going to, let's see, 1, 2, 3, I don't have enough of those. I got enough purple ones, okay? So if I build a rectangle off each one of these sides, and then I bring up my lateral faces, okay, and then I have a base on the other side, another trapezoid that's parallel and congruent. And this would be called a trapezoidal, because the two parallel congruent bases are trapezoids. A trapezoidal prism, and it's a prism because your lateral faces are all rectangles. Okay? Now for your prism, a cylinder, by the way, is in the family of prisms, right? Because it has 2 parallel congruent circles for bases. But you also have another one over here, your rectangular prism. So, showing you the sheet that I've taken some notes on here. Okay, so rectangular prism has its own formula. You can use this one. Same with the cylinder, you could use this one. But obviously, if you find a more specific shape here, I would use that. I want to talk about, really quickly, make sure you know what a cube is. So, let's see, if I have squares on every side. Okay, so this is a cube, alright, like a dice is a cube. A cube is a rectangular prism, okay? Alright. What else do I need to talk about? Okay, so now what I need to talk about is, alright, so you have a cylindrical water tower, and you're like, oh, I know that vocabulary. This is cylinder, so this is a cylindrical water tower. I found it, I found it. Except now you have a decision to make. What formula are you going to use? Now sometimes they just say, hey, find the lateral area. Okay, you have an abbreviation box here that tells you LA is lateral area. So if they tell you, great, that's easy. But they could say this instead. They could say, what's the cubic capacity of a cylindrical container? Or how much water can I fill a cylindrical water tower with? Okay, so you're going to recognize a volume problem because a volume measures the interior space. Right? So if I'm talking about filling a pool or a water tower, I'm talking about how many cubes, what's the cubic capacity inside. If I counted up all the cubes that I could fit in here, right? So, volume is measured in cubes, and I've got these notes here for you that tell you that. Okay, the interior capacity, how much is going to fill it, they're measured in cubes. So another dead giveaway is when the units of measure and your answers are cubes. Okay, so then surface area, what does that measure? Surface area is measuring the outside, and it's measured in squares. So how many squares are on the exterior of this rectangular prism? Now, there's 2 different kinds of areas, okay? So there's surface area and lateral area. Surface area is going to be all of your faces, so every single side of it. So, for example, let's do the triangular prism. My daughter just snuck in here. Okay, so here's my triangular prism. Surface area is going to be the area of all these sides. Sure, why don't you build something? Okay, so surface area is going to be all this. So let's lay this out flat again. If I was finding the surface area, I'm finding the area of every single side here. If I said how much plastic to build this triangular prism, you would calculate the surface area. Okay? So then what's lateral area? Well, let's say I don't want the triangles. Okay? I only want the lateral faces. Remember, lateral means sides. Okay? So, lateral area would be just the rectangles in this one. Okay? In a pyramid, surface area would be all of it. Okay? And lateral area would not include the base. Okay? Whoops. A pyramid. Okay. So, no base, lateral area. Okay? No base. I can put my hand right in there. There's no base on it. That's lateral area. If I wanted to build including the bases, I'm talking about surface area. You want to show them? Slide it over. Show them the pyramid you just made. Good job. What kind of shape? What kind of pyramid is it? What shape is the base?
A square.
That's right. So it's a square pyramid.